Section 8.3. Testing a claim about a mean. In this section, we are going to use a hypothesis test for population mean, which is mu. The objective for this section is to use a formal hypothesis test to test a claim about population mean, which is mu. Notation: N is a sample size, X bar is sample mean, S is a sample standard deviation, mu of X bar is population mean. The requirements for testing claim about population mean. First, the sample is a simple random sample. Second, either or both of these conditions are satisfied. The population is normally distributed, or N is greater than 30. Example 1. A group of students estimated the length of 1 minute without reference to a watch or clock, and the times in seconds are listed below. Use a 0.10 significance level to test the claim that these times are from a population with a mean equals to 60 seconds. Does it appear that students are reasonably good at estimating 1 minute? My original claim is mean equals 60 seconds. I am going to do the hypothesis test in order to test this claim if mean is actually equal to 60 seconds. These are the 8 steps that I have to do in order to finish the hypothesis testing. First step, original claim. Mu equals 60. If the original claim is false, then mu is not equal to 60. For HO and HA, I will pick the statement with an inequality for my HA. And my HO always contains the equal sign. In order to determine whether or not my test is two-tail test, right-tail test, or left-tail test, I am looking at the inequality of my HA. HA contains not equal to, that means I am going to have the two-tail test. For significance level, most of the time it's going to be given from my problem. Use a 0.10 significance level. So alpha is 0.10. If alpha is not given, please use 0.05. For test statistic and p-value, I am going to calculate it using StatCrunch. I have already imported my data in here. We are going to click on Stat, T-Stats, one sample with data, because I have the raw data. Choose a column where you save your data. In here, mu equals to 60, and we select not equal to for HA. Compute. This is the test statistic, and this is the p-value. For test statistic, I get T equals 2.54, 358, 67. I am going to round it to 2 decimal places, which is 2.54. And p-value is 0.0234. I am going to round this to 3 significant figures, which is 0.023. To make my decision whether or not I reject my HO, I compare my p-value with my alpha. P-value here is less than alpha, which means I am going to reject my HO. For the conclusion, if you still need help, please visit the chart in section 8.1 to help you with that. From here, I have 2 different statements. HO says that mu equals to 60 seconds. HA says that mu is not equal to 60 seconds. And in my decision, I reject my HO. So when I reject my HO, that means I say, I don't think that is equal to 60 seconds. That means I think that is not equal to 60 seconds. Example 2. A data set about speeding dating includes like ratings of male dates made by female dates. The summary statistics are n equals 198, x bar equals 7.83, s equals 1.94. Use a 0.05 significance level to test the claim that the population mean of such rating is less than 8. Assuming that a simple random sample has been selected, identifying the null and alternative hypothesis, test statistics, p-value, and state the final conclusion that addresses the original claim. So in this problem, instead of giving me the raw data, they gave me the summary statistic. These are the numbers that I need for my calculations later. Use a 0.05 significance level to test the claim that the population mean is less than 8. My original claim is mu less than 8. My first step, the original claim, mu is less than 8. If mu is less than 8 is false, that means mu is greater than or equal to 8. From these two, I will pick the one with inequality for my HA. And my HO always contains the equal sign. HA contains less than, that means this is a left tail test. For significance level, go back to the problem. They asked me to use 0.05. I will use StatCrunch to calculate my test statistic and p-value. Stat, t-stats, one sample with summary. In this problem, I don't have the raw data, but I have the summary. Sample mean, 7.83. Sample standard deviation, 1.94. Sample size, 198. For HO, mu equals to 8. And for HA, I will choose less than and compute. This is my test statistic, and this is my p-value. For test statistic, I get t equals negative 1.2330474. And I will round it to 2 decimal places. So I get negative 1.23. For p-value, I get 0.1095. And I round it to 3 significant figures. And I get 0.110. To make my decision, I will compare the p-value and the alpha. Since p-value is greater than alpha, I do not reject HO. For the conclusion, you can always go back to the chart in section 8.1 to help you with restating your conclusion. From here, if you look at these two hypotheses, HO says mu equals 8. HA says mu less than 8. I failed to reject HO. That means I did not reject HO. That means I think that is equal to 8. That means I don't think that is less than 8.